Research on learning to improve scientific inquiry skills and cultivate scientific wisdom. Members of the study. This time, Kenichi Goto will give a presentation. Please see this page for the research outline. 1. Background of the study. In science education as it is currently practiced in Japan, excellent practices and research have been developed for acquisition of knowledge, and it has been reported that Japan has always maintained a high level in international academic achievement surveys. On the other hand, the application of knowledge, which should be emphasized, is currently left to the abilities of individual learners. The stages of inquiry are classified into several categories, from setting the problem to writing the report, but there is no known method for steadily accomplishing each stage. However, there is no known method for steadily accomplishing each of these stages. The only known method is a standardized sentence, Teikei Bun, Matsubara, 2001, 6 in the report writing stage. This is the basic model of evidence-based thinking, which is a formula made up of only the essential elements for judgment. Since the achievement of all stages of inquiry is meaningful, we decided to apply the concept of Teikei to create a basic pattern as a means to support the achievement of each stage of inquiry, and to develop teaching materials and teaching methods that utilize the pattern. The purpose of this study is to examine curriculum development and evaluation methods that aim to cultivate the required scientific wisdom and improve scientific inquiry skills through the utilization of knowledge through scientific inquiry using the basic pattern. The scientific ability to use knowledge and thereby cope with problematic situations, CO, 2009, 6 is defined as scientific wisdom. Awareness, which is regarded as a manifestation of scientific wisdom, is necessary to drive inquiry. The concept of the study is a cycle in which the accomplishment of inquiry leads to the acquisition of verification data and the improvement of inquiry skills. The data provides a basis for evidence-based thinking in the wisdom of science, and the absorbed knowledge becomes the wisdom of science, leading to awareness. For this purpose, we believe that a basic pattern for each learning process is necessary. The basic pattern is a method to support the accomplishment of inquiry by applying and developing the concept of fixed form, see below, of fixed form instruction, Matsubara, 2001, which was clearly effective in describing results and discussions in report writing. To examine the process of inquiry, we focused on the NGSS framework. It is composed of 3 pillars, 1. Practices, 2. Cross-disciplinary concepts, and 3. Core ideas. It advocates practices as an inseparable part of knowledge and skills, and distinguishes between 2 types of practices, scientific and engineering practices, left column in Table 1. The practices of the components have much in common, indicating the close relationship between scientific inquiry and engineering design practices. Both are truly inquiry activities. The framework questions the so-called learning by tracing the process of inquiry, but in addition to the significance and value of inquiry, it points out the importance of criticism, which has not been focused on in the past. There is no mention of criticism in the elemental practices. There is a difference between scientific practices and engineering practices in numbers 1 and 6. The scientific practice emphasizes the process of formulating questions and explaining the answers, while the engineering practice emphasizes the process of identifying and accomplishing tasks. As mentioned above, we are promoting research using the basic types for each of the processes shown in Table 1. In this section, we will discuss learning activities using the F-Mutual Evaluation Sheet, which is an initiative that shows the total learning process for improving scientific inquiry skills and cultivating scientific wisdom. The purpose of this course is to understand and share the basic pattern in peer assessment activities and the basic pattern when expressing records by conducting peer assessment activities. The method involves 5 steps, as shown here. The learners make their own blocks of their choice, leave descriptions freely, and enjoy the learning process. By evaluating each other's writing, learners will naturally learn what is important to record. In addition, the students learn the importance of assessments evaluation and the ability to point out the good points and areas for improvement of others in a straightforward manner by being aware of the basic form Teikei when evaluating comments. 1. Learners created their own original works, and all of them completed them in about 5 to 6 minutes. 2. The learners used various expressions and took about 15 minutes to finish. 3. All the students had a photo function on their cell phones, and they used it to record the pictures. Learners will make various block shapes. They also keep a record of various descriptions. No one makes the exact same block shape, and no one keeps the exact same paper records. 4. All learners were able to reproduce the block based on the record in about 2 minutes. 5. It was decided to judge whether they could reproduce the block or not within 3 minutes. The factors that determine whether or not a block can be reproduced depend mainly on the creator's factors, the shape of the created block and the quality of the written record, and on the factors of others who are trying to reproduce it, their ability to read the record. Some examples of peer evaluation charts are shown below. Name of the person who evaluated from the left column. Time to reproduce. What was good about it? Points for improvement. Write these down. For example, Ms. D took only 44 seconds to reproduce the block in her self-assessment. However, Ms. E, who tried to recreate Mr. D's block, took 3 minutes. Ms. F was able to recreate the block in 1 minute and 17 seconds. 6. The students were given about 5 minutes to discuss, and each group extracted about 3 to 4 elements. 7. There were various elements necessary for recording from each group, but the elements necessary for recording were roughly categorized as overall diagram, diagram of parts, procedure, and supplementary explanation, text, color, etc. Both the expressions in the creation and the recording are different for each person, but through the efforts using peer evaluation and discussion, we realized that the necessary elements for recording can be summarized into about 3. Conclusion. In this report, as an example of the mutual evaluation approach, we learned the basic pattern in peer evaluation activities about the elements necessary for expression related to scientific inquiry and the wisdom of science through the study of block materials, and furthermore, we were able to understand, share, and deepen our thoughts about the basic pattern in recording and expression. References. End of my presentation. Thank you very much for your attention.